All right, lesson number 2, we're going to be talking about estimating angles. Okay, so we know that estimating is an important skill that we need to know. In this case, our lesson is going to help us determine an angle measurement without having to use a protractor. Okay, so learning how to use one, but learning how to not use one using your eyes. Okay, and estimating, you know what, that's probably a 45 degree angle, 22.5, whatever angle you're looking for. You should be able to estimate or have a good idea of how to do that. Okay. So for example, when you stand up straight, your body is actually at a 90-degree angle to the floor. Probably the room in which you sit at the moment has many examples of right angles. Okay, the walls meeting the ceiling, the floor meeting the walls, and the moldings around the door. Right angles are easily identified. Okay? Similarly, examples of 180 degrees or straight lines are equally obvious in your life. Any flat surface makes a straight angle. Okay? So when we're estimating angles, okay, what we wanna do is subdivide. Okay, so for example, we have here is a 90-degree angle. Okay, so this should have been. Let me write this better. So we have E, B, and D. So we call this angle EBD, right? B being our middle part here, which is the angle that we're looking for. Okay, so we should be able to determine that this is a 90-degree angle. Okay, but what if I wanted to find a 45-degree angle from this? Okay, well, we know 45 is half of 90. So when we're drawing our line here, okay, we want to draw it halfway in, okay, and make sure that looks. So the first thing I did was draw the straight lines, draw my 90-degree angle. Don't like my box too much. Basically, we want to cut this in half to represent not 45 degrees. So my vertex, which we have over here, I'm gonna make a line so that it's about halfway in. Okay, just like that. So this whole thing, as we agreed, is 90 degrees. Okay, but what about now this? Well, this now becomes a 45-degree angle. Okay, and so all I simply wanted to do was bisect. So now that we've bisected it, okay, we call this angle DB, and we're gonna make this new line F. Okay. So we had angle BD, or angle EBD was the 90-degree angle. Now that we formed a new angle here, right here, with 45-degree angle here, this becomes a new angle, as you can see here. Now we have FBD. Okay, so this becomes now angle FB. Oops, looks like a P. FBD equals 45 degrees. Okay, whereas angle EBD equaled a 90-degree angle. That's how we get it to half, right? Okay, here's another example of what I mean here. So we have angle FBD. Okay, so our angle in this case is a 45-degree angle. But what if I wanted to find half of that? Okay, well, I need to know what half of 45-degree angle is. Okay, well, in this case, it's 22.5. Okay, so half of that, just like we did with the 90-degree angle, our vertex is right here. We want to go halfway in. Okay, obviously not to scale, but the point is we're looking for half. Okay, in this case, so we have a 22.5-degree angle here. We also have to name our new angle. So in this case, it's not angle FBD anymore. Let's put, for example, G. You can put any letter really. So our angle in this case would be GBD. Right, so halfway bisecting, we got 22.5 degrees in this case. So those last two examples work really well because we're only finding half. Right, it's easy to find what half of something is, or to have accuracy. Okay, remember that. Keep in mind that estimation is just trying to be as accurate as possible. What's the most appropriate angle there? Right, we're not drawing a 180-degree angle when we can see that it's really probably a 40-degree angle. So just keep that in mind. The next two examples, here, will give you kind of an idea of how to estimate when we can't find exactly half. Okay. So for example, the first example we have, so imagine that this, okay, again, is a 45-degree angle. We'll use F, B, and D again. Okay, except this time we're not looking for 22.5 degrees. We're not looking for halfway in this case. We're looking for a 20-degree angle. Well, we still can use the halfway mark. So this is 22.5 degrees. And we're looking for a 20-degree angle. Okay, well, is it higher or lower? Okay, it should be lower. Okay, we know, right? It can't be more, it can't be higher than 22.5, 20. So we're looking for something a little bit lower. Likely, if I would estimate, probably somewhere around there, or even closer. Okay, so when we draw our line, not to scale as I said before, but when we draw our line, actually I'm gonna make it a little bit nicer. Let's do this again. This is what happens when you're holding the camera and drawing at the same time. So let's say halfway, say about, because my markers are a bit bigger, it's touching the points, but when you have your fine pencil, okay, this is about 20 degrees, I would say. Okay, but you can see that the lines are relatively close to each other. Okay? We can also call this a new line. So we have G here, we can call this H. So this becomes, we have angle FBD. So angle FBD equals 45 degrees. We have angle GBD, which equals 22.5 degrees. Okay, and now we have our new formed angle, angle HVD, which equals now 20 degrees. Example here, same rules apply. So this time we're same thing. So we have a 45-degree angle in this case. We want to bisect it halfway to get 22.5. So we have it halfway at G here. Okay, but now we're looking for an angle of 25 degrees in this case. So we know that it's more than 22.5 this time. So we want to lift it a little bit higher, our angle here, okay, to represent about a 25 angle degree. We know it's still far apart from the 45-degree angle, okay, but still close enough at the halfway mark there to identify. Okay, and then we put our angles here together. So we got angle FBD. FBD should be what? Well, it should be 45 degrees. I said that. Okay. Our next one is GBD, which is our halfway mark, should be 22.5 degrees. Okay. And our I, okay, so our letter here is actually I, B, D. Our angle will be 25 degrees. All right, so the last example dealt with 90-degree angles, 45 and half of 45. In this lesson, or this part, I'm going to show you that you can also do the same thing with 30-degree and 60-degree angles and dissecting them. Okay, so you should have a good idea of what a 1/3 sort of looks like. Okay, in this example, I'm kind of showing you here what a 90-degree angle looks like. So when you have a quadrant that looks like this, every part is a 90-degree angle here. Okay, we have our labels in this case, A, B, C, D, and in the middle we're going to call that O. Okay, so if I were to dissect this right off the bat, okay, I know that I have an angle of COB, or COB, if you want to call it, angle COB should be 90 degrees. Okay, COB, if we're looking at the whole thing, we're looking at a 90-degree angle. Okay, but finding 60 and 30, well, we have to bisect the lines. So in this case, I bisect the lines a little bit here, so that I had, in this case, a 30-degree angle here, okay, and a 60-degree angle here. I'm looking for thirds. Okay, I'm cutting this into thirds. Okay, well, a third of 90, okay, is 30. A third of, or 2/3 of 90 is 60. Okay, and then a full 3/3, right, would be, in this case, a 90-degree angle. All right, so let's label our stuff here. So we have our first is our 30-degree angle here. Okay, so if we're looking at it from this line to our angle here, that's 30 degrees. Okay, so we can label this in many different ways. I'm gonna label it K. Okay, so our new angle now is KOB equals 30 degrees. Okay, so remember that you have angle here. Okay, you have your angle COB, angle KOB. Okay, and in this case, we're gonna label this I. Okay, and this angle now becomes this whole thing. Well, 30 degrees plus another 30 degrees should get you a 60-degree angle. So approximately this should be about 60 degrees. So remember, it's the whole thing, not just the part. If I was just looking for the part, right, those would be 30-degree increments. Okay, but in this case, I want the whole thing. The whole thing is 60 degrees. So angle I, O, and B equals 60-degree angle. Okay, and so that's how you bisect if we were looking for thirds. Okay, so the next part to this is, what if we're trying to estimate a 35-degree angle in here? Okay, what two reference or what 2 points are we going to use, okay, in order to find a 35-degree angle? Probably not in between here, right? We're estimating probably not in the 90 to 60-degree range. Okay, but is it in the 0 to 30 range? Probably not. It's more than, right? It's more than 30. So it's likely going to be somewhere in between here. Okay, so if I erase this, okay, and we're looking for 35, it's closer to 30 degrees. Okay, so our line really shouldn't be getting anywhere closer to the 60-degree angle that we have here. Should be pretty close to the 30-degree angle. Again, my marker is a little bit big for this, but you'll be able to use this with pencil. Okay, so that new line that we have there, okay, will become our 35-degree angle. So let's call this L. So this whole thing right here now becomes a 35 degrees. So when we write it down, we have angle LOB. So we're gonna lob that up like a basketball. 35 degrees. All right. Okay, we're gonna talk about one last concept dealing with angles here. Okay, so imagine this nice little pizza has to be sliced up. Okay, well, you have to estimate your angles at which you're looking for. Okay, so for example, a medium slices, okay, from a pizza cut into 8 pieces, for example, whereas a large would might be cut into 6 pieces. Okay? With the pizza cutting tool, you need to cut the pizza in the center point and have the pieces at equal size. But before you start cutting through the pizza, you need to have some idea as to what angle will be. The first cut should be the half, okay? So as I did here, I cut the pizza in half just so I have a better idea of what I'm cutting exactly, okay? So our diameter, or the straight line in this case, would be what? 180 degrees, okay? 6 pieces require that each half is cut into thirds. Since 1/3 of 180, so 180, if I just wanted to know what 1/3 of would that be, okay, well, I'm looking at a 60 degrees. So my angle at which I'm cutting it at should be 60 degrees, okay, or 1/3 of the pizza. So how do I cut that? Well, I want 1/3 of a cut in this case. Well, we've done 1/3, we've estimated that. I put the points just to help me just give a little bit of an idea of how I'm cutting it. So in this case, I have my points here. I approximated this is about 1/3. Okay, this is probably 1/3. So boom, right there, 1/3, 1/3, 1/3, and I do that with the other half of the pizza. Okay, it's almost like you're making a peace sign, okay, with the pizza. Okay, so in this case, not as equal as I'd like it to be, but again, we're just kind of approximating here that I have 1/3. So I should have 6 slices. 1, 2, 3, 4, 5, 6 slices ready made and ready to go. Okay. We have another example here that I'm going to show you of when we're dealing with medium pizza, when we want to cut into 8s or 45-degree angles. The next example, pizza wants to be done in medium pizza, so we want a 45-degree angle from this. Okay, well, we have our 90-degree angles, so if I calculate all these are all 90-degree angles. But we want 45-degree angles because we want 8 pieces. This gives us 4 pieces. We want to cut these into halves. Okay, so if we cut these into halves, okay, this becomes a 45-degree angle. So if I count 1, 2, 3, 4, 5, 6, 7, 8, I should have 8 pieces, 45-degree angle. That's how I slice it up in 45 degrees, okay? But what you have to do first is do it in a 90 degrees, okay? It's easier to cut it in half when you're doing this, okay? Just keep that in mind, okay? The last example that we're going to finish up today is if I were to ask you, it's in your notes here, how to estimate for the angle of 120 degrees. Okay, so we're estimating what that would look like. Okay, so if we were to draw our straight line, we're going to need a straight line this time because it's more than 90-degree angle in this case. Let's make this into a half. Let's cut it into half. Okay, we should have 90-degree angle here, 90-degree angle here. Okay, but we want 120 degrees. Okay, so, well, how are we going to do that? Let's say that we use this side as our 90-degree angle. Okay, how are we going to use this side, okay, this 90-degree angle to find 120? Well, we're going to use what? 1/3, right? If I had estimated that this is about 1/3, we have our 190, we have about a 30-degree angle. Well, that equals to 120. Okay. So in this case, let's label this B, O, and M. How's that? BOM. In this case, angle BOM or MOB is equal to 120 degrees. Okay, knowing that I know that this is a 90-degree angle, and I'm trying to get 1/3 of this 90-degree angle, that gets me to a total of 90 plus 30. 120 degrees.